So in KS test, we have seen to reject a null hypothesis. Again, just as a quick recap, the null hypothesis in KS test, the null hypothesis in KS test is that given two distributions, given two random variables x and y and their distributions, the null hypothesis is that both these are generated from the same distribution, right? The probability distribution of x and y is the same. That's what is a null distribution. Here I have clearly stated in the original content videos itself that we reject the null hypothesis. The null hypothesis is rejected at a significance level of alpha if the supreme, so DNM here is nothing but the maximum gap or the maximal or the supremum of the gap between both the CDFs, right? When that is greater than C alpha under root n plus n by nm, where n and m are the sizes of the first and second sample. So for random variable x, you have a sample, right, of x1, x2, so on, xn, right? Similarly, for random variable y, you have y1, y2, so on, so forth, ym. These are all the values that you have, right? And this is what we showed. And what is C alpha here? There is a table for C alpha, but C alpha is generally taken to be equal to square root of minus half natural logarithm of alpha. So let's just use this, because the question here, the question that one of our students asked is, how do you compute the p-value here? In all of hypothesis testing, we learned that first we compute the p-value, and then if the p-value is less than alpha, then we reject a null hypothesis. This is what we learned. This is what we learned. But here we are not talking of p-value, we are not talking of p-value or anything. Why are we going into this? So the other question is, what is the actual p-value of a KS test? So let's work out some of those things. It's not very hard. It's fairly simple. And let me just change the color here. Okay. And the mathematics is simple. So first things first. The first thing is we reject a null hypothesis. H0 is rejected. This is basics of hypothesis testing, right? This is the basic concept of hypothesis testing, right? H0 is rejected, right? At a significance level, or often said at a level alpha, if the p-value is less than alpha. First statement. Second statement. Okay, this is the general concept of hypothesis testing. And what we discussed in this video here is we reject, for a KS test, whatever video that we have already seen, we said that we reject. H0 is rejected. H0 is rejected if the DNM, the maximum gap, right, is greater than C alpha square root of n plus m by nm. So now let's try to combine both of these concepts and compute the actual p-value itself, step by step. Okay, from now onwards, instead of writing d n comma n, I'll write this as d, just for notational simplicity. There is no point of mentioning n and m here, because I understand that because I'm using n and m in the formula here, I'll just replace d and m with d itself, just for simplicity, nothing else. Okay, so let's go step by step, right? So if I assume, if I let d and m be equal to d, just for notational simplicity, just for notational simplicity, just to simplify the notation, then when do I reject? So I reject my null hypothesis. I reject my null hypothesis if d multiplied by square root of nm by n plus m, if it is greater than C alpha. But in this, we also see that C alpha has this equivalent formulation. So let's write that down. So C alpha is equal to square root of minus half natural logarithm of alpha, right? We already have this formula here, right? So in other words, this implies we reject the null hypothesis if d into nm by n plus m is greater than square root of minus half natural logarithm of alpha, right? So which is nothing but if I square both sides, my greater than still stays the same. So it is d square nm by n plus m, right? It will be greater than minus half of log alpha. Now, since this is a negative sign, if I multiply both sides by -1, my sign will get inverted. So this is equal to minus d square nm by n plus m. Simple algebra. I'm not doing any magic here. This is simple algebra, simple inequalities, right? Now let's go and work this out, right? So what do I have here? Minus d square, right? So what do I have here? Minus d square nm by n plus m, right? If it is less than half of natural logarithm of alpha, then I reject my null hypothesis. That's what I started off with. I reject my null hypothesis if all of these are happening, right? So now if I multiply both sides by 2, I get minus 2d square nm by n plus m, right? And the inverse of log is exponential function, right? Is e power. So if I do exp of this, which is less than equal to alpha, right? Basically, I moved the 2 this side and I computed the inverse function of log. Natural logarithm, the inverse of natural logarithm is e power x, right? So e power log x or natural logarithm of x is x. That's what I simply used. Now what is my statement now? Where did we start? So we reject null hypothesis if this value is less than equal to alpha. That's where we reached. And what is the actual mathematics? We reject h0 if my p-value is less than alpha. Now look at the formulation. In hypothesis testing, I reject my null hypothesis. So I reject my null hypothesis if p-value is less than alpha. Here, from this formulation, this is what we started off with. When I simplified it, I got to a statement where that I reject null hypothesis if this value is less than alpha. So what will this value be? This value be equal to p-value now. So the p-value in KS test is equal to this. So your p-value is a function of the number of points that you have, the number of samples that you have for random variable x, the number of samples you have for random variable y, and the maximal gap or the supremum of the gap that you have between the two CDFs. I hope this simplifies and explains you how to compute the p-value for KS test. This is, and all that I have used is simple geometry, so simple algebra, simple inequalities, nothing else, nothing very fancy here. So I hope this question is clarified now.